Welcome to our last lesson in financial mathematics, and in this lesson we are going to look at changing parameters. We want to look at how the parameters can change and the overall effect of the same parameters on both the simple and the compound interests. The parameters that we are talking about are the amount. The second parameter is the principal. That is the principal amount. We can also talk about the interest. We can also look at the rates. And lastly, we will talk about the period. We want to look at what are the effects of changing these parameters on the compound interest and the simple interest that can be calculated. If you change one of the parameters, you will discover that there is an overall change in the end results that can be obtained when using the compound interest and the simple interest formula. Maybe just a reminder, let us state the compound interest formula. The compound interest formula has the amount, the principal, the rate, and the periods. These variables, we have already discussed them in our previous lessons. A stands for the amount, P stands for the principal amount that can be invested or borrowed. This R stands for the rate of interest, the rate at which the interest is to be calculated, and small letter n denotes the periods. This second formula is the simple interest formula. The variables therein have also been discussed. I stands for the simple interest, P stands for the principal, R stands for the rate, and T stands for the time or the duration. These rates can be expressed as a fraction or a decimal number. It is important to take note of that. And lastly, for us to get the compound interest, we get the difference between the amount and the principal. These two are the interests. The last one is the formula for calculating the compound interest. And first of all, you must get the amount before you subtract the principal for you to get the interest. These two formula, we already know them. So we want to look at examples where we'll be varying these parameters, and we try to look at their overall effect on the other parameters in a given relationship, whether in compound interest or the simple interest. That is what we are going to do. So let us move on and look at examples. And in our first example, we are going to consider two parameters. We are going to look at the effect of changing the periods and its overall effect on the rates. If we change the period, how will the rates be affected? That is a salient question that we are going to answer in this lesson. In our example number 1, if you invest $5,000 determine the interest rate per annum in 2 decimal places if the total amount is approximately $7,500 after 5 years. If part A, the interest is compounded annually. We want to determine the interest rate when the compound interest is compounded annually over a duration of 5 years at when the total amount at the end of it all is $7,500. So just like the way we were doing in our other lessons, if you are given such a question, you are supposed to have some systematic steps that should be followed to handle the same. And these steps starts from the first one where we are supposed to list. The first step is for us to list the various parameters or constants together with the values assigned to them. So when we look at the question, we are given several parameters. The first one is the principal amount that is going to be invested, which is 5,000. The second one is the amount, which is 7,500. We have also been provided with the period, and this period is 5 years. Remember, we've been told to calculate the interest rates per annum. So it means we are not going to make any adjustment on our period. We will use the period the way it is. But any variation in the period will also, any variation in the rates will also attract some adjustments on the period. After we have listed these variables down, we said that we go ahead and write down the compound interest formula. That is the second thing we are supposed to do. And just a reminder that the compound interest formula is A is equal to P into bracket 1 plus R raised to power N. These are the variables we have. After we have written down this formula, the third thing we are supposed to do is to substitute in the values provided, and the fourth thing is for us to evaluate. So here we've been provided with the amount. The principal is 5,000. This will be 1 plus the rates that we are going to calculate, raised to power n, and n is our period, where we have 5 periods. So we want to get the value of r from this equation. We proceed with the solving, and the first thing we are going to do, it is prudent that we divide all through by 5,000 on both sides. Whatever is done on the right hand side should also be done on the left hand side. This 5,000 and this will cancel. So ultimately we will have 1 plus r raised to power 5 being equal to 7,500 when divided by 5,000. This will give us 1.5. We have a power here that we are supposed to bring down. We can decide to introduce log on both sides of the equation, or we use a calculator and introduce the fifth root. We find the fifth root. We find the fifth root on both sides. So here we are going to have 1 plus r raised to power 5 we have agreed we introduce a fifth root on both sides. So if you find the fifth root on the left hand side, this will give us 1 plus r. And if you find the fifth root using your calculator on the left hand side, this is the same as 1.5 raised to power a fifth, and this will give us 1.0845. So this means our r will be equal to 1.0845 minus 1, and our rate will be 0.0845. These rates are usually expressed as a percentage, and we have learned how to convert a decimal number to a percentage number. That is basically by multiplying the given decimal number by 100, and when we multiply this by 100%, it will give us a rate of 8.45% per annum. 8.45 per annum. And remember, in the question we are also instructed to calculate the rates per annum in 2 decimal places. We have achieved that. We now move on and look at the second part of this question. The second part. Let me write there my rates, because for the purpose of comparison much later, for the purpose of comparison. The second part is for us to calculate the rates if the interest is compounded quarterly. If the interest is compounded quarterly. Just like in the first part, we should list down the variables. Now, when we are talking about the quarterly compounding, it means that we are going to have some adjustments in our periods, because we are told the duration is 5 years. But in a year, how many quarters do we have? We have 4 quarters. So it means in 5 years, we are going to have 5 times 4 periods. And this will give us 20 periods. That will give us 20 periods. And the rate that we are going to get will be the rate per quarter, which will require us to convert to the rates per annum by multiplying by 4. So after listing the variables, we move on and write down the compound interest formula. Then we substitute in the values. Just like in the first part, we divide through by $5,000 so that our R raised to power 20 will be equal to 1.5. And for us to get to remove this power here, we introduce the 20th root on both sides. We introduce the 20th root to remove the power. And this, on the left-hand side, if we introduce the 20th root, we are going to remain with 1 plus r. And this should be equal to, when we look for the 20th root of 1.5, it will give us 1.0205. Just a reminder, maybe you might not realize what we are doing here. When we talk of a number, let us take up a pronumeral m, which is raised to power 20, and we want to get the 20th root of this. Remember, a raised to power the root of a is the same as a raised to power a half. So the 20th root of a is the same as a raised to power 1 out of 20. So that if we have the 20th root of a raised to power 20 is the same as a raised to power 20 multiplied by 1 out of 20. And the rules of indices dictates that these powers will multiply, and when they multiply, 20 and 20 will cancel, leaving us with a raised to power 1, and any number raised to power 1 is the same number. This is a. That is why when we are looking for the 20th root of the value in the bracket here, which is also raised to power 20, we are getting that the contents of the bracket, that is 1 plus r, which we are equating to the 20th root of 1.5. So from this we can have our rates being equal to 1.0205 minus 1, and r will be equal to 0.0205. We multiply this by 100 to convert to percentage, and r will be equal to 2.05% per quarter. Remember, we were calculating, we were using quarterly compounding. So this rate that we have obtained will be per quarter. And the question requires us to find the rates per annum. And in a year, we have 4 quarters. And for a quarter is equal to 2.05%. So for 4 quarters, the rates per annum will be 2.05% times 4. This will give us 8.20%. That will give us 8.20%. Let us confirm that value. This is the percentage we have. So when this compound interest is going to be compounded quarterly, we are getting the rates of 8.20% per annum. So the periods have changed. Our first periods were in terms of years, 5 years. We've now moved to quarterly. And the last part of this question is we calculate the interest rate if the interest is compounded weekly. If the interest is going to be compounded weekly. So you remember that the other variables or the other parameters, that is the amount and the principal, will remain the same. But when it comes to the period N, it will change. We have 5 years. And in a year, we have 12 weeks. So in 5 years, we are going to have 5. In a year, we have 52. We don't have 12 weeks. Rather, we have 12 months in a year. And in a year, we have approximately 52 weeks. So that means in 5 years, we are going to have 5 times 52 weeks. This is going to give us 260 periods. So that in our compound interest formula, where we have n, we will replace with 260. So we substitute in the values as they were, and we try to calculate the rates so that we'll compare the rates at the end of it all. The amount is $7,500. The principal amount to be invested is $5,000. The rates are what we don't know. Those are what we are trying to find out. So from this, we can still divide all through by 5,000. 5,000. So that this and this cancels. And we are going to have 1 plus r raised to power 260 being equal to 1.5. So to remove this power here, we introduce the 260th root 260 on both sides. root 260 on both sides. And when that is done on the left-hand side, we are going to remain with 1 plus r, giving us the 260th root of 1.5 is 1.00156, is approximately 1.00156, so that our r will be equal to 0.00156. And this to be converted into a percentage, we multiply by 100, giving us the rates of 0.156%. This is per week. These are the rates per week. And the question required us to calculate approximate rates per annum. So if these are the rates in a week, and in a year we have 52 weeks, what will be the rates per annum? We multiply this value by 52, and this will give us 8.11%. 8.11%. So the rates here will be 8.11% per annum. Do we notice any changes in the rates as a result of us changing the period, the number of periods? We should have realized that, because when it was compounded annually, the rates were 8.45% per annum. Then when we moved to quarterly compounding, we are getting 8.20%. And weekly compounding is giving us 8.11% per annum. So let us move on to the next question and see what it requires us to do. The last part of this question is, what is the effect of changing the period on the rates of compound interest? What is the effect of changing the period on the rates of compound interest? A good question. We will realize that in the first case, part A, we only had 5 periods. In part B, when we moved to quarterly compounding, we ended up with 20 periods. And part C, we've had a whopping 260 periods. So the periods are increasing. What is the effect of increasing periods? Automatically, it is clearly shown here that when the periods increase, the rates decrease. When the periods of compounding increases, the rates decreases. The rates decreases. So we can also have something like this, that they have an inverse proportion relation. There exists an inverse proportion relationship between the number of periods and the rates. When the periods increases, the rates decreases. That is what we have. That is what we have. So in this first example, we have just been varying the number of periods. vis-a-vis the rates. And we have observed that when the periods increases, the rates decreases. That is what we have. That is the effect on the equilibrium that exists. Let us look at another example. And this example is in form of a table. We are instructed to copy and complete the following table if compound interest is applied. Copy and complete the following table. If compound interest is applied. In the first column, we have the principal. We have the principal. In the second column, we have the rates. In the third column, we have the period. Just reduce the size a bit. We have the period. Then we have the overall time. Overall time. Then we have the interest. And last we have the amount. In the first two rows, we have the principal being $7,000. So in the two, we are going to compare using a principal of $7,000. We will be looking at the rates when the period is annually. Even here it is annually. The overall time in both cases is 5 years. We will also look at the interest, given that the amount is changing. In the first case, we have $87,500. And in the second case, we have $10,500. So we need to calculate the rates. We need to calculate the rates when the amount has changed. And in the second case, we will be comparing the amounts when the principals are changed. In fact, in the first, we have a principal of 9,000 and it has been doubled in the second case to 18,000. To $18,000. And the rates are the same, 8% per annum, 8% per fortnight, because they are comparing fortnightly. Fortnightly. The overall time is 2 years in each case. We will also calculate the interest. In the first two, we need to get the rates and the interest. In the second two, in the second pair, we need to have the interest and the amounts. So let us calculate them so that for the purpose of comparison, we need to calculate them first before we start comparing. And we have been told that this is compound interest. So we don't have any other method or a formula to use other than the compound interest formula. We write the formula down. Amount is equal to the principal into 1 plus the rates raised to n. When it comes to the first one, the amount we are told is $87.50. And the principal given is 7,000. It is going to be compounded annually. So that means we have a total of 5 periods. A total of 5 periods. We divide by 7,000 on both sides, so that ultimately our 1 plus r raised to power 5 will be equal to will be equal to 1.25. So for us to remove this power, we get the fifth root, just like in the first example, the fifth root on both sides. And this will give us 1 plus r being equal to 1.0456, and ultimately our R rates per annum will be 0.0456, which we are supposed to convert into a percentage by multiplying by 100%, and this will give us 4.56% per year, 4.56% per annum. So we come and fill here. The same should be done when it comes to the second row. The amount provided has changed. The amount has changed from $87.50 to $10,500. So we are going to use $10,500, and the principal is still the same, $7,000. The number of periods will still remain 5. When we divide all through by 7,000, we are going to have 1 plus r raised to power 5 being equal to 1.25, so that we can introduce the fifth root on both sides. Will it be the same? Not really. Let us divide first. $7,000 divided by 10,500. What are we going to get? You can try that using your calculator. This is giving me 1.5, so that we can introduce the fifth root on both sides. And 1 plus r, we will get this to be equal to 1.0844, so that our rates will be equal to 0.844. And when we convert this into a percentage number by multiplying by 100, we are getting 0.0844 times 100, it will give us 8.44%. So this is what we have. So what are we observing? We can observe that the rates, when the amount changes, it means that the rates have changed. When the amount changes from $8,750 to $10,500, the rates have actually almost doubled from 4.56% to 8.44%. So there is a direct proportional relationship between an increase in the rates and the increase in the amounts. Can we be able to calculate the interest in the first pair? Remember, in compound interest, we say that interest is calculated from the difference between the amount and the principal. So in the first row, the amount is $87.50 and the principal is $7,000. When you subtract, you will get an interest of $1,750. In the second row, the amount is $10,500 and the principal is still $7,000. So when you subtract, you will get $3,500. So when you try to look at the change in the interest rate and the interest obtained, you will discover that when the interest rate is doubled, you will realize that the interest obtained is also doubled. This is 4.56%, this is 8.44%. So it is like the rate have doubled, same to the interest that has doubled. Let us compare the last two. Let us compare the last two and see how the changes in the interest will affect the amount. So we are provided with the principal, the rates, the duration of the periods can be obtained from this, and we can be able to calculate the amount. We are still going to apply the compound interest formula. In the first row, the amount is not given, but the principal is given is 9,000. The rates we've been given 8% fortnightly. The rates we've been given 8% fortnightly for 2 years. So 8%, we need to convert it to a decimal number. 8%, when you divide that by 100, you'll get 0.08. 0.08. And when it comes to our periods, we have 2 years, and it is going to be compounded fortnightly. It means after every 2 weeks. In a year, we have 26 fortnights, and in 2 years, how many fortnights are we going to have? We are going to have 52 fortnights, and hence those are the periods we are going to use. So we have 52 periods. So we have 1.08 raised to power 52. Then we multiply that by our principal. Let us relook at 8% being divided by 100. It is 0.08. Then we add 0.08 and 1. Then we multiply by 9,000. This is giving us 49,200. Let us re-examine this. These rates that we have been provided. The rates we have here are per annum. This rate should also be per annum. So that for us to calculate the rates per fortnight, we will divide this by 26 to get the rate per fortnight. And that will give us completely new rates. 8% divided by 100 to convert to a decimal. Then we divide by 26 fortnights. We will get 0.00307. Then the periods we have agreed, there are 52 periods in 2 years compounded fortnightly. So this will be 1.00307 raised to power 52 multiplied by 9,000. And this will give us 10,555.21 dollars. This is the amount. The amount in the first case we are getting 10,555.21. What will be the interest? The interest is basically the difference between this and this one, and when we subtract, we'll get 1,555.21. That is the interest. Let us look at the second one. The amount will be equal to, in the second case, you will realize that the principal has been doubled from 9,000 to 8,000. So our amount will be calculated from the new principal. And the rates will be 0.00307. This one is raised to 52. And this will give us we are getting an amount to the tune of $21,110.43 dollars. so that when you subtract the principal from that, we will get 3,110.42. Try to compare them. What is happening when the principal amount has been doubled? When the principal amount is doubled and the rates remain constant, compounded through the same periods, you'll discover that the interest is also doubled. The doubling of the principal amount also doubles the interest. This is what we can make as a discovery. And in summary, we can say that a change in the rate, that is, if it is positive, if you increase the rates, you are also increasing the interest. If you increase the principal amount to be invested or borrowed, you are also increasing the interest. These are the two important variables or parameters that we can compare from this. And of course, if you increase the duration, in other examples, if you can look at examples where the duration has been increased, you will discover that an increase in overall time will also increase the interest, because we have looked at an increase in periods, where in the first example where an increase in the periods led to a reduction in the rates. It led to a reduction in the rates. This is what we have. So having looked at these parameters, I now want to give you an assignment. And in this assignment, we are told determine to one decimal place. A, determine to one decimal place the equivalent simple interest rate for the following. Investments over 3 years. Roman 1, $8,000 at 4% compounded annually. Roman 2, the same amount, $8,000, but at a double rate, which is 10%, which is 8% compounded annually. B, if you double or triple the compound interest rate, how is the simple interest? How is the simple interest rate affected? How is it affected? So in this question, we are supposed to make comparisons between the compound interests that will be obtained when compounding annually and when using the simple interest formula. I know you are well conversant with the compound interest formula and also the simple interest formula. So maybe just to give you a hint on this, you are supposed to calculate both the compound and simple interest in the two cases before you start comparing them. And with that, this marks the end of our chapter on financial mathematics, where we started from percentages, conversion of units from percentage to decimal, and to fractions, and vice versa, to up we are the last one where we have been changing parameters to see the effect on the compound interest results and the simple interest results. I want now to welcome you in our next lesson, where we will be looking at measurements. That is a new chapter and very interesting. Welcome and thank you.